Okay, we're looking at the section 1-4, and this should be review, but it's multiples, lowest common multiple, and lowest common denominator. They're kind of doing the same thing. Okay, so I'm going to kind of run through this, and hopefully this should be somewhat review, something you've seen before. There's two different methods for finding the least common multiple, right? Or lowest common multiple. It depends on how you want to say it. One of them, you just list everything out and try to find at what point do they intersect. So you had two numbers, 4 and 6. This is our example we have here. So 4, it goes 0, 4, 8, 12, and 6 was 0, 6, 12. And they say, oh, they both have 12 in it. And once they both have 12, you say, okay, least common multiple, we'll make it 12, right? I prefer the method 2 because it's going to be used in other subsequent parts of doing things. And I say this because it's in the next section. This is what they're going to use. So I've been writing them out linear, right? And I've been putting lines in class. And the reason why is it makes it a little bit easier to see. So let's take number 4. 4 and its factors would be 2 times 2, right? And then we have 6, right? And that's factors are 3 times 2. Well, the lowest common multiple of this, okay, we know this would be 2 squared. And this would be just the same thing you see right here, right? Is the greatest number of times that occurs in any of the numbers, and then you put them together. Well, you could say, well, 2's in there, but it's 2 squared shows up in the 4, so you put it 2 squared here. 3's not in this one, but it's in this one, but you have to include it. It has to have every number. So basically 2 times 2 is 4, 4 times 3 is 12. That's how you would get the number. And I'll show you why this is the preferred method, because you're going to use it in the next sections. Makes it a little easier if you're using that method. Okay, let's say you have two numbers with variables in it. That's what this one is right here. This says 35x squared, right? So I'm just looking at the examples in your book, right? And you say, let's break this apart. This would be 5 times 7. That's what it's doing. And it says it has two x's too, x and x, right? That's where it gets its x squared, right? And let's look at the other one. It says 175 xy, okay? And if you break this apart, it's 5 times 5 times 7 times x times y, okay? All broken out. Now, when you get into it, you know for a fact, everybody has to be accounted for and the lowest common multiple, right? So you got to have a 5. But if we look at this, this one has 2, so you have to have 2. This has a 7, this has a 7, so that's fine. Just 1 7 is needed. It covers both of them. This has x, right? And this one has y. This has 1x, this has 2 x's, so you have to have 2 x's. And this is 1 y, you have a singular y, right? This has no y, doesn't matter. You have to have at least 1 y for that guy. Okay, so what happens is these get multiplied. How do I have a square on the 7? That's not right. There's no square there. It's only 1 7. Sorry. Anyways, so it's 5 squared times 7 ends up being 175. Okay, x squared is going to come down, and then y squared, and that's why you get the number you get right here. Let's take a look at the next thing. All right, let's scroll this guy down. Oh. Okay, stop. And least common denominator. All right, this is where all this stuff starts coming together a little bit, right? So they give you 3 values, 1/12, 3/16, 5/18. And you can add and subtract any fraction just as long as the denominators are the same. So you want to make the denominators the same. So how you do that is basically the prime factorization of each value, right? This is written out. So what I'm going to do is I'm going to try to make this a little bigger, and then we can look at it instead of me rewriting it. Oh, too big. Go back a little bit. There we go. Whoa, just a little bigger. There we go. Anyways, looking at the way this is, 12 is 3 times 2 times 2, right? 16 is 2 times 2 times 2 times 2, right? That's 2 to the 4th. And 18 is 3 times 3 times 2, right? So the end product of this is you got to cover the highest multiples of each one of these things. For the 2's, obviously 2 raised to the 4 would be the winner, right? For this one, it's 3. There's only one group that has 3 in it, and that's 18. And it says 3 squared, so we're going to put him here, right? This 2 is covered in this one. This 2 squared is covered in this one too as well. So we're done, right? So in this case, you would just multiply these two together to get 144, right? So the least common denominator is going to be this. Now, take this thing one step further, okay? So if it's 144, how would you do this thing with the fractions? How could you add them together? I think you might remember. So I have 1/12, right? 3/16, and I got 5/8. No, 5/18, okay? Looking at the way this thing's set up, right? You can relax back and see these other parts of this thing and see how they kind of relate. And I'm going to show you a neat shortcut. If you've done this thing correctly, it's going to be kind of easy, right? Right? So, okay. So for the 12, okay, you could tell that the numbers were used 3 times 2 to the 4th, right? This one is the least common multiple is 2 to the 4 times 3 squared, right? So what did I not use? I mean, what did I use in here? It's not shown in there. We know a 3, you have to use another 3 to get it to look like this. And you got to use 2 squared, right? So it's 2 squared, 4. 4 times 2 is 12. So these were multiplied by 12. This is by 12. So the fraction for this guy would be 12 over 144. Okay, let's try the 16. This is 2 to the 4. That's 2 to the 4. So what's not being used? 3 to the squared, which is 9. So I would have to multiply this by 9 and this one by 9 to get myself 144 here. And 3 times 9 is 28 on top. Okay, it's the cheat. All right. The next one is, of course, 18. 3 squared is being used. 1, 2 is being used. This makes this 2 to the 3. All right. So whatever this is, multiplied by 2 to the 3. So this times 2 to the 3, which is 8. And this is multiplied by 8. This will give you 144. And this is 40. So if you wanted to add the fractions together, it's a lot easier if you're using that prime factorization method. All right. So if that was my problem, minus 12. Oh, it says minus 3/16 plus 5/18. Okay. I'd use these numbers instead. For 1/12, I put 12 over 144 minus, instead of 3/16, I'm going to use 28 over 144. And then I'm going to add, instead of 5/18, 40 over 144. Okay. So my answer would be essentially 52 minus 28. I should do it like this so I can see what I'm doing. Let's clean that up. All right. 52 minus 28. 12 minus 8 is 4. 4 minus 2 is 2. So it'd be 24 over 144 would be my final answer for this thing. Of course, let's keep reducing this since we're learning this in class, right? This would be 24. This would be 144, right? What you could do is you could also think this is 12 times 12, right? So let's do this one. This is 2 times 12. This one's 12 times 12. See where we're going here? We could turn around and cancel these out now, right? Because they're over top each other. And since this is a 2, what can you do? And that's a 12. This ends up being 1/6 is the final answer if you added them all together. All right. So this is a powerful tool because you go back and find out what you didn't use. It's part of this and just multiply it. We'll do problems like this. Don't worry about it. Not that you are worried about it. Well, let's try this one. This has one with the variables, algebraic fractions, right? So we have 6c over 5b, 2c over 15b, and 7 over 25b. So we're just going to look at the denominators first, okay? So b is 5 times b. 15b it's 3 times 5 times b, and 25b is 5 times 5 times b. So it's 5 squared b. Now look at the way this comes out. You're going to have to grab a couple guys, right? B is obviously in there, right? So this guy, because of this, and this, he's found in each one of them. So he has to be, as far as the least common multiple, he has to be in there, right? Now we have 5s. This has an extra 5, so it has to be accounted for. So that's why it has to be 5 squared. And then you have a 3 found in this one, but not in the other ones. He's got to be in there. This 5 is accounted for by that one. So the answer would be 3 times 5 squared is 20. Actually, 25 times 3, 75b would be the denominator. Now, if I went back, all right, C's on everyone on the top, okay? So if you want, you can go and do this now. Let's not do that one for right now. That's fine. Let's leave that one the way it is. We're going to get more into that. But hopefully this makes sense kind of looking at the way we're doing this. It should pull a little more understanding what's going on. Here's the technique they just showed you. I just did it upstairs, right? A little further up. So you have 2/3, 3/4, 4/5. They're breaking it down to how do you, which at least common multiple each one of these things, and then you're able to basically add the fractions together. They're putting them all out like this, but you would add them if you got to this point. And so when you're in class, hopefully this is going to make a little more sense as you kind of practice them.